So let's take a look at the end behavior for this particular function. Now I'm going to take a look at the limit. You know what, let me change colors there real quick. I don't like that. There we go, that's better. The limit as x goes to infinity of 2x cubed minus 4x plus 1 over x minus 1. Now I'm going to have the highest order of the denominator is x to the first power. So if I multiply all this by 1 over x over 1 over x, I'm multiplying by 1. I end up with the limit as x goes to infinity of 2x cubed over x minus 4x over x plus 1 over x, x over x minus 1 over x. Now this will cancel and give me an x squared. These x's will cancel, that won't. These will cancel, just give me a 1 right there. So what I actually have is the limit as x goes to infinity of, what was that? That's 2x squared minus 4 plus 1 over x, all over 1 minus 1 over x. So in the limit, this will go to 0, and this will go to 0. So in the limit, this thing is going to look like 2x squared minus 4. Well, 2x squared minus 4, this will go to infinity, so this limit equals infinity. Now, once again, if I want to find out what that oblique asymptote is, I know in general it's going to be a quadratic, but to find the actual quadratic, I need to do long division again. So see, this is going to be x minus 1 divided into 2x cubed minus 4x plus 1. And x goes into 2x cubed, 2x squared times, which gives me 2x cubed minus 2x squared. I'll subtract. Oops, this is a cubed. Sorry, that goes away. Now I'm going to have 2x squared minus 4x plus 1. And then let's see, x goes into 2x squared, 2x times. So this is plus 2x. So this is a 2x squared minus 2x. I'll subtract again. That goes away. This becomes addition. This is a negative 2x plus 1. X goes into negative 2x plus 1, negative 2 times. So this is negative 2x plus 2. Subtract. Sorry, I'm definitely kind of losing room here. This becomes negative, so this is a, oops, this is a positive 2x, or positive 2 here. So that's actually what I did. I wrote it down wrong, but I did it right here. So now this would make this a positive 2. And this is a positive 2. And this is a negative 2. Sorry, I kind of messed up my signs there a little bit. That's a negative 2. Now I'm going to do the subtraction. And I'm sorry I ran out of room. I'm going to move it up here. This will go away. This will be a 3. So this is, back in grade school, it was remainder of 3. Remember that? Well, that remainder 3 simply comes up here. It's 3 over x minus 1. So that's what the long division is actually equal to. So if I take the limit as x goes to infinity, this will go to 0. So this is actually my oblique asymptote. I'm going to have 2x squared plus 2x plus 2. In the limit, this function approaches that function. That asymptotically, they become the same. I got to be careful by saying they're the same because they're really not. But 2x cubed minus 4x plus 1 over x minus 1 approaches 2x squared plus 2x plus 2. And I can show you that quickly in Maple. Okay, here it is. I went ahead and typed it into Maple. And the red one is our original function. You can see when x equals 1, I have this vertical asymptote here. And this green is what I'm getting really, really, really close to. Now, obviously, I need to increase this before you can tell it's getting really close. So let's go 40. And that's a little bit better. How about 90? And you can see it's kind of obvious that they are, in fact, very rapidly approaching each other. Let's take us out to 150. See how far we can get. And I'm going to need to increase x just a little bit more for me to keep going on the y-axis. So let's try that and jump this up to 250. And then very rapidly you can tell that they're approaching, and you really can't tell the difference between them.